Welcome to NASC 102, the Fall 2015 offering, the Introductory to Meteorology course. My name is Dr. Paul Castleberry, and I'm facilitating this course now for the 8th year, actually. And I've offered this course online for 6 of those 9 years. So what I wanted to do was just welcome you to the course, give you a brief overview of the course, since we start tomorrow, Saturday, August 29th. What you are looking at is our Scholar site, and this is where we're going to be working off of. You'll see the required textbooks, the Essentials of Meteorology. Either 5th or 6th edition will be fine. And then right here you see my contact information. I can be reached by phone. That's my cell phone or email address, as I've outlined right here. Now let's just take a look around this particular site. You'll notice first of all I have the syllabus. And let's just go over this just for a few minutes. So again, you have the contact information up here. One thing I would like to point out is that this is an online course, fully online course, but I do offer online office hours twice a week. Online Tuesday and Thursday, 7 to 8 p.m. via WebEx. That is an online site. In fact, let me go ahead and just log into it here a moment. I'll just kind of tool around here for a moment. Now, the office hours are not required. It's not a mandatory attendance because this is an online course. But I would encourage you, if you have any questions, and surely questions will come up as we go through the course, and that would be a good place to start, is to drop by the virtual online office hours. Now, what you're seeing right here is just my login. You're not going to have to do all of this. I'll send you a link to access the online office hours. But you can see I've offered this course before, and I've had office hours in the past. But there's more to come on that. So let's just say if I decided to set up a meeting now, I would enter your email addresses here, and then I would go ahead and start it, and you would receive a link on your end via your email. You can click on that and join the online meeting. So that will be a resource that will be available, like I said, Tuesdays and Thursday evenings, from 7 to 8 p.m. Now, if that doesn't work out, if you're taking a course or you have work obligations, certainly, and you want to get online to ask me a specific question, or you need some assistance, we can also set up an appointment on WebEx to meet online as well. So once again, this is a resource available to you. I'll be online Tuesdays and Thursday evenings, 7 to 8, as we go through this semester. Feel free to join me if you have any questions. Now, I won't be doing any lecturing or anything like that in these online office hours because I have already provided lecture videos for you as we go through the course. Now, as we continue to look through the syllabus, I have 6 objectives for this course. And basically, I want you to have a basic understanding of the atmosphere and things that occur in the atmosphere and how those things can influence our planet and our lives as well. I want to also provide you with a background in weather to be able to make informed decisions on local and national issues. Global climate change has been a huge, huge issue in terms of pro and con. Depending upon where you stand on the issue, that's been going on for at least 25 years. There's a debate, and hopefully after taking this course, you will have learned enough to engage in discourse with those that would like to talk about these types of issues. Now, the real fun part of the class is this thing we call the weather forecasting exercise. And I'm going to show you how to actually access the weather forecasting exercise and how to make weather forecasts. Now, the assumption with this course is that you know absolutely nothing about weather forecasting. I have laboratories built into this course to help you learn how to forecast for temperatures, how to forecast for rain, how to forecast for cloud cover, multiple things that meteorologists do in the real world. By the time you're done with this course, you will know how to, actually the first 7 or 8 weeks of the course, you'll learn how to forecast. Simulations, using real-world simulations to construct your knowledge of principles related to energy, related to atmospheric moisture, and other types of things. I want you to understand the scientific method. That is a critical principle to learn, the scientific method of discovery. And most importantly, I want you to learn science by doing. For many of you, this is the only science course that you will have. Now, this particular course is the Engaged Citizenship curriculum, and specifically scientific reasoning. It will satisfy those particular parts or components that Simpson requires. I will fill these in as we go through the course, and also, besides scientific reasoning, you will have quantitative reasoning as well. In other words, you'll be able to put numbers together to form opinions, informed educational opinions on topics related to meteorology. Now, the design of the course, like I said, it's an online course. Each week, online lectures, labs, forecasting assignments. It is really critical that you put in the necessary time and effort into this course. In fact, you see right here, the average time spent working in this online course is at least 12 hours per week. Sometimes the misconception, especially if you haven't taken an online course before, is that it doesn't require a lot of time and effort. In fact, it oftentimes requires more time and effort than in a face-to-face course. And so you'll spend your week doing video modules, working on assignments. Back when I offered this course in fall 2004 was the last in-class version. We met for 4 hours per week. That was on a Saturday. And then there were about 8 hours per week spent on assignments. So even the the in-class session spent at least 12 hours per week. The first 6 or 7 weeks of the course, for about the first half of the week, you'll spend anywhere from 12 to 20 hours per week, because we've got to learn how to forecast. That's going to require time commitment from your end on that. Now, the course is a 4-credit course, and as a result, we're required to have at least 144 hours of engagement in the course. You see the breakdown of the lecture activities. Those lectures will occur with weekly videos, and I'll talk about that here in just a little bit. But throughout the entire semester, you'll spend about 56 hours viewing videos. And then, of course, making weather forecasts. We're looking at about 40 hours for the semester. Group discussion topics, another 9 hours. Readings from the text, 14. And so you see how this basically breaks down. Some of the topics that we will cover in this course, we will talk about energy, temperature, atmospheric moisture. Now, you think about this a second. Energy, temperature, moisture, by itself doesn't seem like very interesting topics. But when you're forecasting the weather, you have to understand the concepts related to energy, and related to temperature, and related to moisture, and related to stability. So that's part of the crux of this forecasting exercise. It's taking concepts that you're going to learn about in this course and applying them in a real-world scenario, like weather forecasting. Everybody talks about the weather. And I've had students who come back to me after taking this course and they say, Paul, I was at work and somebody knew I was taking this meteorology course and they asked me about the weather, and I could actually show them how I can forecast for the weather. So this is something that you can actually take and use long after you're done with this course. And you see some of the other topics that we cover as well. Now the course basically has 6 parts to it. Our online lectures, labs, activities, discussions, everything will take place online. You see the date from August 29th to December 18th. I'll have supplemental material provided on your Scholar site. For weather forecasting, you're going to make at least 30 individual forecasts. So there'll be 30 days during the semester at least that you'll forecast for. Now what's great about that is I'm going to take your best 25 forecast scores. So it doesn't penalize you to make as many forecasts as possible. I'm only going to take your 25 best forecast scores and use those for the grade component of the forecasting. So if you're going to make 50 forecasts, I'm going to take your 25 best forecasts. If you only make 25 forecasts, then I have to take those 25 forecasting scores there. We will have homework, quizzes, assignments, again via Scholar. Discussion topics are going to be with me. I'm kind of going back and forth on this. I might end up making this discussion topics in groups, where as a group you will converse online and answer questions related to discussion topics. Stay tuned. I'm still kind of mulling that one over. We'll have exams and other assignments as deemed necessary by myself or you. There's the required textbook. Under weather forecasting exercise, I give more information, basically just what I said. But you're going to get to use your newfound knowledge. You're going to apply concepts related to energy to actually forecasting for temperatures. And in fact, I'll hold up here. I don't want to go too far ahead. But you will be required to make at least 30 forecasts, and I'll use your 25 best. So it really is in your best interest to make as many forecasts as possible. Laboratory exercises. The purpose of lab exercises is simply to reinforce the materials that you've learned from lectures and be able to, for me to be able to evaluate how well you understand the concepts presented. So we will be doing labs and homeworks as we go through this course. The best way to learn science is to actually do science. Now the policy for exams, assignments, etc. Now these assignments will be up at least 6 days ahead of time, and this course moves pretty quickly. We've got a large class. We've got approximately, I think, 22, 23 students in it. So we have to keep in lockstep as we move through the course. So there are no makeups of missing exams, assignments, etc. There are no opportunity for extra credit points. So in other words, if you miss any of these assignments, you earn a 0 for that particular exercise. But I will have the assignments out at least 6 days before they're due. Now, when I say at least 6 days, as we go through the course, I'll start opening up more and more of the course, and you can actually work ahead. So you have an opportunity to work ahead in the course. And so it is possible you could finish the course possibly in late November, since this is an online course, and you'll have that ability to work ahead if you so desire. You see the grading scale here. Now, in this course, like I said, I've been teaching at Simpson since 2007, so yeah, 8 years. It's hard to fail this course. I'll say that again. It is simply difficult to fail this course. If you stay on top of your assignments, if you're viewing your videos. One thing you'll find in the videos, oftentimes I'm doing portions of the labs or the assignments in the videos. So you have a great advantage to make sure you view those videos very carefully. I give a lot of hints. Here's the breakdown by percentages. We'll have quizzes that make up 15% of the exams, of the grade. Online assignments, problem sets, homeworks make up another 15%. Group discussion topics on forecastings and simulations make up 5%. Notice we have 5 exams, but each of these exams only make up 5% of your grade. So a single exam or a single set of exams are not going to impact your grade that much. Now the big weight is with laboratory assignments. They make up 20% of your grade. So you're really going to want to focus your efforts into the labs, the quizzes, the forecasting, and other assignments. Now, in terms of the communication policy, I've outlined that here. I've got a full-time job at Iowa State University. I work in the College of Engineering at Iowa State University. I'm what they call a classification officer. So I certify graduation for the College of Engineering. I also work with course availability for math and for chemistry at Iowa State University. And so I am busy during the hours of 7:30 to 5, tied up with that. But feel free to call me anytime between 6 and 8 p.m. during the weekdays and weekends. I mean, if you call me at 9 o'clock, I'm not going to hang up on you. But feel free to call me if you have any questions. Some people prefer email in terms of contact. That's fine as well. Keep in mind that I will have office hours each Tuesday and Thursday night from 7 to 8. So if you have any questions, feel free to drop by there. I would also encourage you to review the academic integrity policy. You want to make sure that the work that you are doing is your own. It is critical. And so there are consequences for cheating, plagiarism, any unauthorized collaboration, etc. There are policies in place to deal with that. Hopefully that's not an issue, and has not been an issue in the past, and I'm sure it won't be an issue in the future. Now, if anyone needs disability accommodation, we have the website here for that. And if you do have questions in terms of the disability accommodation, please feel free to let me know, and I'll make sure you get to the correct resources. I have some acknowledgments for this syllabus. You see some of the individuals that I have pulled information from with their permission and direction to help build this syllabus. So, in the span of about 15 minutes, I went through the syllabus. Let's actually go through and take a look at the course on Scholar. Now, like I said, this is broken down by weeks. So the first week, we start tomorrow on Saturday. So this course runs from Saturday, August 29th, or at least the first week, until Friday, September 4th. All of your assignments are going to be due on Friday evenings, no later than 11:55 p.m. It's critical that you make note of that. Weekly assignments, labs, quizzes, homeworks, exams, etc. are due no later than Friday, 11:55 p.m. Now you notice for the first week, I have some videos for you to view. I have a YouTube video, hint for determining atmospheric pressure from the station model, homework number 1. So if you look down here, I have a homework number 1 on the station model. I also have YouTube video hint for determining atmospheric pressure. So apparently pressure is part of this first assignment. And then I also have a YouTube wind direction video hint for station model, homework number 1. So make sure you use these resources to help you with homework number 1. So if I click on homework number 1, you'll see a Word file is downloaded. And for homework number 1, there are 4 problems. There's problem number 1, problem number 2, 3, and 4. So 4 problems on this assignment called Station Model Homework Number 1. Now to do this basically, let me show you what a station model is. Let me just pull something up here a moment. Now this is a picture of a station model. In other words, let me go over here a second. Now you will notice I have a link here called Station Model, and a station model is used to observe current conditions at a particular location. Let me just show you. If I click on here, you see a map of the U.S. Let me see if I can make this a little bit larger. And you'll notice these circles with lines coming out of them, and you'll also notice there's information at each of these stations. So this particular one here is Minneapolis-St. Paul, and as you're going to learn from this particular exercise, this provides us with the air temperature, 73 degrees Fahrenheit, the dew point temperature, which you'll learn later what dew point temperature means, is 60 degrees Fahrenheit. You'll also learn about the wind direction looking at the station model. From the station model, I see a southeast wind. In other words, the winds are coming from the southeast. That's how we measure, or that's how we determine wind direction, where the winds are coming from, not blowing to, but where they're coming from. And so you see right there we have a southeast wind of 10 knots. Now right now, if you're viewing this welcome video, you do not know how I'm coming up with these, but using the materials that I'm providing in Scholar, you'll learn how to interpret the weather in shorthand notation. This 156 is actually barometric pressure, and it actually measures 1,015.6 millibars, but all you see is a 156. Notice that you have shorthand notation. That way we can fit a large amount of weather information about a particular station on a large weather map here. If I go down to Florida, down here to Miami, I see we have a temperature of 87, a dew point temperature of 74. I see that it has a quarter cloud cover. I also see that it has an east wind at 5 knots and a barometric pressure of 1,015.2 millibars. Now, how do I know all of this? Well, there's an Appendix C that I've attached that's from your textbook, and it tells me how to interpret all of this. So, for instance, at a station model, I see this top number here, 48, corresponds to temperature. I see this number corresponds to dew point temperature. I see that this circle here corresponds to the amount of cloud cover. So I have a completely closed circle, which means overcast. So I'm going to put the overcast. So you get the idea of how this works. In this particular area, we talk about the winds, and this particular one shows a wind speed of 10 knots. I would prefer for this exercise you use knots and not miles per hour or kilometers per hour. So you've got plenty of information here to help you interpret a station model. And that's what you're doing. You're learning how to interpret a station model with this first exercise. Now notice I have some video hints here for determining atmospheric pressure and for determining wind direction. So make sure you do those. You click on that, and you'll see a YouTube video pop up.
Okay, the next question from your colleague is, how can we tell wind direction? We know that wind speed is...
And notice it's only a 2-minute, 28-second video. So that information is available for you. So, you should be able to handle homework number 1. Once you are done, so basically with homework number 1, you'll take it, download it to your computer, and you'll fill in the temperature. I'll do the first one here for you. 55 degrees Fahrenheit. Okay, make sure you include your units. So for temperature, it's degrees Fahrenheit. Dew point temperature is 37 degrees Fahrenheit. Wind direction for this one is southwest at 15 knots. Again, please be sure to include your units. Units such as degrees Fahrenheit, knots. Actually, it's just asking for wind direction here, so southwest. And the wind speed is 15 knots. Cloud cover, 25% of the circle is covered. So 1/4 is cloud cover. Atmospheric pressure is 1,013.8 millibars. Again, the units for pressure, as you're going to learn, is millibars. The pressure change, we have no pressure change recorded here, so none. And the current weather, these three, looks like diamonds, but they're really circles. Here is moderate rain. So I've been able to interpret the weather for this particular one here. Now when you're done, obviously make sure you put your name in there, so I know who it is. So for instance, once you're done, you will save it to your computer. Number 1. And then you will submit it and submit your homework. You're going to click on this link here, click on this to submit homework number 1. And since I am in instructor mode, I'm unable to do that. But you will be prompted to upload the Word file into Scholar, and then I'll get notification once you have uploaded it. There's also lab number 1 and a lab number 0. So make sure you complete those as well. Lab number 0 is how well do you know your syllabus. There's a series of questions that you'll answer that when you get to that. And lab number 1, to actually make forecasts for this course, we're going to have to create, or you will have to create an account on ClassNet. And let's see. Just notice here I have a short YouTube video on how to submit your homework assignment. Here's a very short video under homework number, just 4 problems for local on that. Then you will come to, so make sure you go to that to learn how to submit your video. Well, for this one, for lab number 1, I have a video. It's a 4-minute, 34-second video that shows you how to go into ClassNet to create your ClassNet account. Well, welcome to the course. I hope you're going to enjoy it. I certainly enjoy facilitating it. And if you have any questions, just let me know. Now, what I would recommend each week on the videos, make sure that you have viewed all of the videos by no later than Sunday. So each week we'll start on a Saturday, and I would highly recommend that you complete your viewing of your videos over the weekend so you can spend the rest of the week working on the assignments. You don't want to get behind. If you wait until 2 days before to start viewing the videos and trying to do the assignments, you'll find it a very frustrating experience. So I encourage you to treat this like an in-class meeting, even though it's online. Make sure you budget your time accordingly. Okay, I look forward to engaging with all of you this semester, and have a good day.